Does your past still exist? What if I tell you that the memories you made, the days you passed, the time that you spent together with your family and friends, all of them are currently existing in real time? How would that sound to you? Pretty strange, right? The past is actually a phenomenal moment of time that has a collection of billions and trillions, or maybe even more number of events that took place or had occurred. But does it still exist in any meaningful way? Is it just a fixed and unchanging reality that we can only remember and study, or is it something that continues to exist in some form, even as we move inexorably forward into the future? This question has captivated some of the famous scientists and businessmen such as Stephen Hawking, Neil deGrasse Tyson, Michio Kaku, and Elon Musk for years, and the answer is pretty shocking. And this video will reveal it to you. So don't miss a second and watch till the end, as you'll get to know a whole lot of things you never even thought to be possible, because the past is not gone as we thought. It is 100% out there. Time, the elusive and enigmatic concept, has captivated the human mind for millennia. We measure it, we track it, and we try to control it, yet it remains one of the greatest mysteries of our existence. But what if the past, which we believe to be gone and irretrievable, still exists? What if the events of yesterday are not just memories but are still happening somewhere, somehow? Think about it. We experience time as this unstoppable force that just keeps on ticking. We have this moment we call now, but as soon as it's gone forever. And what's even insane is that we never know what's going to happen in the next moment. It's like we're constantly riding this wave of unpredictability and surprise, just bursting with the potential for whatever's coming next. It's both exhilarating and kind of scary at the same time, don't you think? Our perception of time differs greatly from what physics tells us. The individual who discovered this was none other than Albert Einstein, who had a remarkable understanding of this subject. Most of us view time as something that ticks away at the same pace for everyone and everything. So if 1 second goes by for me, it passes for you too, and even for those fluffy clouds up in the sky. That's what makes time so universal. Hermann Minkowski, a well-known German mathematician, noticed something fascinating about time in relation to Maxwell's equations of electrodynamics. He realized that time could be treated as a dimension rather than just a parameter. He compared it to a ball that remains the same regardless of its orientation, just like Maxwell's equations remain unchanged when space is rotated into time. To address this, Minkowski combined space and time into a four-dimensional spacetime, allowing space to rotate into time. This unification of space and time explained why Maxwell's equations have the symmetry they do, not just because of electric and magnetic fields, but also due to the fundamental properties of space and time themselves. Truly amazing. Let me explain to you with a diagram. Let's consider two straight lines that represent time in at least one dimension of space. This kind of drawing is called a space-time diagram. Now, here's the interesting part. If you're standing still, your path in this diagram will look like a straight vertical line. But if you start moving at a constant speed, your path will look like a straight line that's tilted at an angle. And if you change your speed, your path will start to rotate in space-time. And did you know that the fastest speed possible in the universe is the speed of light? It's usually drawn in the diagram at a 45-degree angle, according to traditional approach. In space, we can move in all directions, but time only allows us to move forward. Time has been identified as a dimension, which means it's just a label for coordinates. It's uncertain what being a dimension really means and whether other dimensions exist. Einstein was the one who first got this concept, and to understand it, we need to agree on four things. Number 1, light speed in a vacuum is finite. 2, nothing can go faster than light in a vacuum. 3, all theoretical observers' viewpoints are equally valid. 4, the speed of light is always the same in a vacuum. These four ideas make up Einstein's theory of special relativity. And get this, even though we're talking about theoretical observers, their viewpoint is just as valid as yours. Most of us use now to refer to the present moment without worrying about scientific details. So why not agree on a shared understanding of now, like using a flat line on a space-time diagram? That way, we can talk about what's happening now without any confusion. If you want to make this more about physics and not just a diagram, you'll need to figure out a way to measure what we mean by now. That's where an operational procedure comes in. Einstein actually came up with a really cool way to do this through something called a Gedanken experiment, which is also known as thought experiment. The idea of this experiment is to place a mirror on your right and another on your left at a fixed distance from you. This will create a space-time diagram that you can use to experiment with photons. You'll send one photon to the left and one to the right, making sure they both leave you at the same time. Then, you wait to see if the photons return to you at the same time. If they don't, you simply adjust your position until they do. It's an interesting experiment that shows the properties of photons and how they interact with mirrors. Discovering the now moment is all about sending photons to two mirrors and being in the middle. When the photons return in half the time, you found your answer. Even before the light reaches you, you'll know the right moment to say now. It's all thanks to Einstein's second assumption: the speed of light is constant. Imagine a person, let's say Michael, is in a rocket moving really fast. If you were to draw a picture of where he is at different times, it would look like a straight line that's slanted. Michael puts mirrors on both sides of his rocket and sends out light beams that bounce back and forth between the mirrors. When the light hits both mirrors at the same time, he knows that half the time has passed. The tricky part is that because Michael is moving so fast, time looks different to him than it does to you. To Michael, time seems to be passing normally for him, but it looks like time is passing slower for you. So Michael thinks that his version of now is the correct one, while yours is not. This might seem strange, but it's actually a real thing called time dilation. It happens because of Einstein's theory of relativity, which says that time and space are connected and can be affected by gravity and motion. So to answer the big question, who is correct? Well, according to Einstein's theory, they're both right. It just depends on your perspective and how fast you're moving. Einstein's theory says everyone's viewpoint is valid, so both people in a situation can be right. But get this, the idea of now changes depending on who's looking. Scientists call it the relativity of simultaneity. In everyday life, slight differences in how people perceive the present moment usually don't cause any confusion. However, if you were zipping around close to the speed of light, these differences would become significant and noticeable. It's like trying to watch the same game from two different stadiums. So in normal life, we don't have to worry about these discrepancies, but if we were moving really fast, it could get pretty confusing. So this might sound a bit trippy at first, but it's actually pretty fascinating. In space-time diagrams, there are some events that can't be causally connected. This means that sending a signal from one to the other would break the speed of light. If you draw a line between these events, it'll have an angle less than 45 degrees to the horizontal. Mirrors don't just reflect our image, they can also help us understand time. In a fascinating experiment, we learned that there's always an observer for whom two events occur simultaneously. Imagine flying mirrors through those events with an observer in the middle and adjust the velocity until the photons hit both events at the same time. Did you know that some events can seem like they're happening at the same time, even if they're totally unrelated? Take a supernova exploding in a galaxy far, far away. Believe it or not, there are some people who would see that and your cheesy dinner is happening at the same time. And then there are others who would see the supernova, and the morning after you feel sick is simultaneous. It's crazy, but it's true. Let's break it down. Something can exist now, even if it's not physically here. And if you believe an event is happening now, and others agree that events happening at the same time also count as happening now, then all those events are equally real and happening in the present moment. In a nutshell, time is all happening at once. Imagine a universe that's like a block of solid marble, unmoving and unchanging. That's the block universe concept for you. It just is, without any coming into being or evolving. If that explanation was tough to grasp, don't worry. There's another way to understand how things exist in relation to Einstein's special relativity. You can believe in something's existence even if you can't see or experience it. But if you only believe things exist when they're present, then you won't arrive at the idea of a block universe. However, this perspective might be even harder to accept. Create an existence definition by picking a specific space-time slice for every moment. It's called slicing, but don't think of pizza. If there are observable effects, it'll clash with Einstein's theories, which have been proven correct. Defining a now that doesn't have an impact is feasible, but why bother? Essentially, space-time encompasses the entire history of reality, where every event that occurred in the past, present, or future has a specific location within it. This means that the past still exists along with the future, but in a different place than our current present. In other words, space-time serves as a container that holds all the events that have ever happened, are happening now, and will happen in the future, with each event occupying a unique and unchanging position within it. Quantum mechanics can't shake up the block universe because it still jives with special relativity. So is the future already predetermined? Some say no because quantum mechanics is indeterminate. They suggest that there must be a special now moment that separates the past from the future. But hold on, the same argument applies to the past too. So as far as we know, the past exists just like the present. What do you think? Let me know down in the comments below. But what if I tell you that we already have a time machine in our universe? Check this video to find out.